When solving problems using the Pythagorean theorem, we're usually left with taking a square root for our final answer, which creates a radical expression. And we want to simplify radical expressions, making sure they have no perfect square factors, that there are no fractions in the square root, and that no radicals appear in the denominator. So we will use the multiplication property of square roots to simplify radicals by removing perfect square factors from the radicand. In problem 10, I automatically know that this is a perfect square, but you might not know this, so you can do prime factoring. So this is 5 times 45. And then we break down 5 times 9. And then 9 is 3 times 3. So this is the square root of 5 squared times 3 squared. Well, remember, when you're taking the square root of a perfect square, it cancels out to be 5 times 3, which is 15. Or you would just know that 15 squared is 225. Simplifying 99, I know this is 9 times 11, and this is 3 times 3. So this is 3 squared times 11. So the square root of 3 squared is 3, and what's left over in our radicand is 11. And that is our simplified radical. 128, I know that's 2 times 64. And then 64 is 8 times 8. Now I could go further and break that down, but that is already a perfect square. It's 8 squared times 2. And I know the square root of 8 squared is 8, and square root of 2 is left over. Now negative square root 60, remember when we take the square root we have both a positive or a negative square root, so this is saying we want a negative answer. Let's break down 60. It's 2 times 30. 30 is 3 times 10, and 10 is 2 times 5. So this is negative square root of 2 squared times 3 times 5. So the square root of 2 squared is 2, and we're left with 3 times 5 in our radical. So that's negative 2 square root 15. So we can use prime factoring to help us break down square roots to simplify them.